So in this video we will study about the energy in food. So this table shows different types of foods and how much energy they releases. So the energy released when 1 gram of food is combust is its fuel value. So if we see this table that says the composition of fuel value of some common food and approximate composition percentage by mass and fuel value. So for an example, carbohydrate have 100% carbohydrate and fuel value is 17 kilojoule per gram. In kilocalorie is 4 kilocalorie per gram. So fat, protein, and then apple, beer also have some food fuel value. Then bread and cheese, eggs. So you can see maximum amount of energy is mostly coming from carbohydrate. It's easy to burn, and this is the way you may have seen different food packaging label that how much kilocalorie burned when they break the combust 1 gram of food, how much energy will release, and based on that they specify that how much energy you will get from each food. So here is one example. The most of the energy in the food comes from the carbohydrate, fat and protein. So carbohydrate gives almost 17 kilojoule per gram, and this is an example for glucose solid. When it burned with oxygen, it produces carbon dioxide gas and water, and delta H, which is a 2803 kilojoule. And when we compare with the fat, which is much higher, almost just double. So this is a formula for one fat which require a lot of oxygen to burn, and then you can see how many times of this fat is giving energy. So protein produces a 17 kilojoule, same as the carbohydrate, and their chemical reaction in the body is not the same as in the calorimeter. So protein burn with a different route compared to the carbohydrate and fats, but the energy value is almost same as the carbohydrate and protein, but fat give more energy and more calories. So next is the energy in fuel. So the vast majority of the energy consumed in this country or in US come from the fossil fuel, and fossil fuel, here is the percentage, is petroleum is give 36%, renewable energy almost 10%, nuclear energy 8%, coal 16%, natural gas is 29%. So this is the energy distribution graph, how much energy come in daily life. And this table says that fuel value of the composition of the some common fuel, for example wood, and then charcoal, crude oil, gasoline, natural gas, hydrogen. So how much each elemental composition is carbon, hydrogen and oxygen. So all these fuel have carbon, hydrogen and oxygen. When they burn, this gave the energy value kilojoule per mole. So you can see the hydrogen is give the highest amount of the energy, and lowest is from the wood. So this is the energy in the fuel. That is why most of the company is producing hydrogen, so that they can burn the hydrogen gas to produce the fuel energy from the fuel. And the last slide in this chapter is this other energy resources. So nuclear fission produces almost 8% energy in the US need, and renewable energy sources are like solar energy, wind energy, geothermal, hydroelectric, and biomass sources produces almost 10% of the energy need. So this is not much, but still is a lot of energy is coming from the renewable energy resources, and this chart is same as the previous one. So still we have to think, keep thinking that what would be the new way to produce the energy, so that we can supply the as required for the, because day by day the energy requirement is increasing. Okay, so this was the chapter number 5, and about the energy from the food and fuel. So you can solve all the questions regarding the thermochemistry, and then let me know if you have any question. We'll try to help you.